name is Marton. I am from Romania, from Transylvania, Hungarian, living in Târgu Mureș. And I will talk to you about BigQuery and architecture, how to wire in your existing products. I will show you how to use JavaScript in SQL. How many of you are using SQL? Great. How many of you have Stackoverflow account? Great. How many of you have like 50 gigabytes of database or are working on databases that are larger than 50 gigabytes? Cool. Okay, so currently every company, as the market is actually evolving into a data company. So even if it's a small shop selling something next to the corner, they have data that they are not leveraging. Without this, they cannot innovate. So it's very important to gather data and actually to leverage all the insights from the data. For a small company, it's very important to do big data tools and to actually run analytics without actually running a dedicated team for it. Why it's important? Everyone talks about big data, velocity, high volume, but actually in the company, they don't have a personnel to do this. Maybe they have 1, 2 developers, but not a team. And all the time, the CEO wants to eventually get some AI from it and so on. But what if there is a solution that the current average developer who knows SQL, JavaScript, can run big data analysis, for example. So making analytics accessible to more companies this is our checklist for it. So we need a backend. We need a database engine for it. We need to run deep analytics. It should be unstructured analysis as well. It should be real-time, terabyte or even petabyte scale now. We should be able to run ad hoc reports. By ad hoc reports, I mean without developer. Suppose that your marketing personnel comes to you, I want to run some reports, and you actually say that, okay, I need a couple of days to build that for you. But what if they could have access via their tools, Tableau and so on, to the data, and they can drag and drop and build the data out of it? It should be minimal engineering efforts, and it should be SQL and JavaScript, which is a very well-known pair. In a legacy business, if we look at it, so usually we have, in my example, we have a web and mobile application. We have a web server, maybe some CMS framework, Drupal, Symfony, whatever, Laravel, or even Java and other technologies. We have cron jobs, we have some batch processing on there, and we have the database, and we cache it, eventually, the report that we run. In the end, we have our dashboards, we have our personnel, and they can actually check the dashboard which we created for it. Behind the scenes, this is actually days to insights. Why? Because cron jobs kicks in minutes. Then maybe it needs to run hours to clean and aggregate. Also batch processing, like Spark instances if you run into more volume and velocity. And eventually, after your ticket was created for a developer, only in couple of days, the marketing team will get the dashboard, will get the insights to it. We need to change this. Nowadays, there are tools to change this quickly, with actually literally a couple of hours of intervention in your existing code. This is possible using Google BigQuery. What is BigQuery? So BigQuery is a warehouse. Is a managed analytics warehouse by Google. By managed, it means that they run it, you just pay them, give the credit card and pay the service, and they take of it all the scalability, all the volume, all the sharding, everything for it. You just actually insert data, you actually query data. And you can also interconnect with all the cloud as well as all Google services. So for example, you can mix Google Sheet, like an Excel representation data, to a database table. And you can write a join. That one table is your table in BigQuery, and the other table is actually a Google Sheet Excel file. Or you can write a query that Google Sheet file is actually joined by a file on the Google Cloud Storage. If you look to the other attributes I put here, it has the CQL 2011 standard, which means that it has all the powerful window functions, partition by things, which nowadays we need to do more analytics. Someone tend to think that nowadays managed services are something else than normal SQL databases. They are not. They are still the same thing. So we have the table, the views, and we have some additional things here, like record, nested, and JSON. This term sounds very handy, the JSON. As for example, as a developer, when I'm putting something in a database, I know that I have 10 columns, but at the runtime, I have 20 other variables or 50 other variables which hold data. And I'm now storing. Why am I storing? I'm not storing because the storage is expensive, it needs to be maintained, and actually it's not the purpose of the business. That's what I know in the past. But now I'm storing everything, all the variables. Actually, I'm putting in a JSON, and I build up my tables that I have all the columns that I need, like 10 columns, and I have the 11th column I call meta. And I put there a JSON in it with all the variables. I don't care. I don't care because it's extremely cheap to store this data. And with that, I'm open all the flexibility to run additional queries about things that I didn't imagine today. Why is this important? After 2 months, someone gets to you, and I want to normalize our show prices into US dollars. Okay, but I don't have granular data. I don't have enough data. I can build it for you, and once I put it live, it will accumulate data. And it will start running from now on. But what if I could already store in a JSON everything, what I had? I could build up the logic, and okay, I have the data, I will write a script, and I materialize that JSON attributes which I pick from here into a new table. It's like actually writing a select statement, this field from JSON, that field from JSON, as a standalone column. And I can use that on the fly for it. Pricing. Since it's a managed service, pricing is important. As you see it, it's extremely cheap. Like the storage is only $20 for terabyte. $20 for terabyte, 1 month. So imagine if you have a 50 gigabyte of database and you put the representation in BigQuery, you are paying fractional of that data. BigQuery pricing is actually also so the queries is calculating in the price, how many analyses you run on it. If you run like 10 terabytes of analytics, that's $50. Usually, if you buy an instance, either on Amazon or on Google, we usually pay at least $150 per month for even for a simple instance. What if you get a big instance like a $1,500, just to run I don't know how many nodes on it? And this is actually the point where it's makes useful as a tool to use as a complement to the database. Okay, let's look how to move to the cloud. So I mentioned you that you have a product and you want to make it available for BigQuery and for analysis. You need to do a pipeline because you will have a lot of events and you need to ship those events to the cloud. Which means that in the end, you will turn out to have an architecture like this. It may look complex, but I will show you how simple this is. So you have different devices, maybe apps, standalone apps, different code repositories for it, each having event sourcing. Servers may have logs for it, and you want to centralize in a central way. We will talk about FluentD, an open source package that we can use to ship all this information to multiple destinations, to multiple outputs. And the FluentD, in our example, will have multiple jobs here. So for example, is that what do we put in FluentD, or what do we route? We route JSON. So in your existing code, when you go home, you write 2 lines. I prepare my JSON structure, and I use a curl URL code that I'm sending that to the FluentD. FluentD runs on the same machine, and FluentD configuration, it will help to do 3 things with that single line. The 3 things you will be that it will haiku cloud storage, so you will have a file with on every line all the events as it happened. It will log to BigQuery, and it will forward to your application. So actually everything will go as it was. It forwards to your application, to your API, or to your whatever backend system. Why it's important is, you just put a new component and you have 3 things here. If you want to add a 5th one or a 4th one, 5th one, like you want to store also in Elasticsearch the same data, or in React, or in Redis, you could the same data wire to other services which actually work out to that direction. Once you have your data in the cloud storage as a file, you have the option to replay. So the replay is actually the most amazing thing that I, developer, do. Usually, like in every 3-4 years, we change the stack of the product. Like, we get a new version, we get a new language, we rewrite it, and so on. But the database is already concluded. Everything is led, and we need to migrate the database. Maybe for MySQL, we need to migrate to Postgres, or from MySQL to, I don't know what service. We need to write a migration tool. And that's, it's complex to write a migration tool when you're changing databases, or when you change the complex. But what if you have the raw data as it happened as a JSON in the cloud storage? You would take all the files, and you would pipeline it before the FluentD. So actually you are replaying what your users or what your application emitted, what your application did. It will take you some time, but when you naturally replay these things, you can build up your next database. And for example, in cloud, you could turn on 10 machines, and you could finish in 1 hour. If you want to finish in sooner, or if you want to finish in 3 days, you have 2 machines, and so on. So this is actually an option of flexibility to it. Now, once you have your data in multiple sources, so your marketing team, not as you as a developer, your marketing team can use their tools like Tableau, Quickly, Data Studio, or you can do your internal dashboards from that data. That data means that you can still use your database to gather, I don't know, user attributes and so on, but you can also read from the analytics database how many actions they did on a form, or how many hours they did, or how many favorites they did, what was the time, and so on. Just small details that you didn't pay attention so far. And this is actually interactive because you can just say to your marketing people that, hey, this is the table, this query, and you need to write now. You don't need to implement it in your system. Now, let's see what FluentD in my example does. So just FluentD is an example to show you, but usually nowadays, also Kafka is a great solution for stream processing. When I mention stream processing, that's another level. Here, let's take at the event source currently. So I will show you these moments. So in a file, in a configuration file, we will have 4 actions. And actually, you install to your machine the FluentD, and you set up these 4 things, and you are actually done. You are shipping to multiple things the same line. We may have a record transformation. You can add additional attributes and so on, change date formats and so on the go. We will have a copy job. The copy job, it means that it will do the same event as a file and also to BigQuery. Let's look one by one to it. The record transformer is great to add additional information or actually to change something which is much more compatible to different systems. Like you may have a date as a Unix timestamp, or you may have a date as an ISO format or local format and so on. You can do this directly in Fluentd with a sample configuration. You don't need to deploy your application. You can just flip on the Fluentd. On the Fluentd, there is a name for the event. And actually, you can choose whatever, front-end user create, front-end user update, front-end user password forget, and so on. Front-end user shop dot added to cart, reach checkout, and so on, for example. But this is unlimited. It's based on you. You can also enrich this data. So you can add like averages on the fly, already compute things to it. Because you may have the data, but you want to ship it forward with additional calculations already done. The copy job is simple. You add the storage, you use the tag as a filter, and you actually slice it by time. Here, the slicing is per day. So it will create different files every day. It can go to minutes, seconds, however you want. And you add the BigQuery configuration. The BigQuery configuration is actually, it says that you need to use the JSON key for it. You have the project, data set, timestamp, and also the table, it's naturally partition byte. So you could use the same time slice to actually wire to the user table on today, user table on next today. But this is naturally just user table. But you are telling the system that it already use as a partition. Ignore unknown values. This is actually my favorite. Why? Because I don't need to pay attention to send only those 10 columns which actually match in the BigQuery database. I can send 50 columns and the additional will be handled. Then it will be placed in the columns and the additional will be handled. Okay, where to use BigQuery? And here, the most important is that BigQuery is a managed service. It's on the cloud, and we need to find out what data to use there, what to duplicate actually in the system. So on the data that is difficult to process, it's okay. At its terabyte scale, petabyte scale even, you can run ad hoc queries and so on. Exploring unstructured data. Like I mentioned, I put all my variables in a JSON, which later I consider as an unstructured data. Not a replacement with additional DBs. So for example, if you have a Magento shop or Drupal CMS, you can still use MySQL or Postgres. You need to use. But with a simple extension, you actually the same data is available in BigQuery as well. And you can actually choose what query to run in your MySQL and what query to run in BigQuery, for example. And the developer favorite is that UDFs, so user-defined functions, create temporary functions, create functions, storage procedures can be written in JavaScript. And this is actually the super goal thing for the developer, because I can write select and so on, and when I have something structured, I can turn into JavaScript code. And this is actually amazing, because everyone knows how to do data wrangling in JavaScript. Let's see an example how we use this data to gather more insights and to reach to analytics. So we actually, Google Analytics, you know, it's a simple script. You put it, all the hits and events are sent to analytics. We change that and we do the same thing to BigQuery. Why? Because we will have access to additional data. We can send the person itself to the hit, because Google Analytics, it's not person-wide, so you don't know who is there. You don't know that it's Peter, it's Alice, you don't know, but you will add. And you store the same data in the BigQuery as well. You can add a lot of custom events to it. They hover at the button, they zoomed in, they spend time on a zoom checking details, I don't know, the t-shirt or a trouser. You may count that as an interest. Later you can follow up with them. Then email engagement. I like very well those platforms who actually have some AI in the email marketing. Like they find out when is the best time to receive the email or to send the email. I usually read my email at 9 a.m. What if we measure this and we find out that you use at 9 a.m., you at 11 a.m. and we send 5 minutes before. They will have first inbox placement. They will have time to consume it. And if you are a marketer, you can use this and leverage this content. The assistant-like experience is also nowadays trendy. Why? Because you measure a lot of events and you can react it. You added something to checkout and you didn't buy it. You can follow up with a chat box or like an email what to do with it. You can recommend other products as well. And the details here is that you have this data and you can store this data. Funnel analysis. So they are doing a lot of steps on the website and I want to find out what path they are actually going on, how they convert, or actually how can I convert them easily. Now, let me show you some SQL from the BigQuery and from it. So first of all, we stored every hit the user does as a website navigation. That's actually the base for this query. And if I want to choose the sign-in page, then the add to cart and checkout, I will have for it the session ID, which may be the user, and the timestamp. After I located the first step, so actually the first step here, it tells me a time. It happened at what time. And in the end, if I join these queries and I say that the second timestamp I am looking is after the first timestamp and the third timestamp I'm looking is after the second timestamp, I end up to build a table which actually tells me which user reached which step of it. The next one. We stored every hit from a website what the user does. And we had a task to distribute and to give attribute like a referrer thing to the first article they visited. And we had a hit list, like 50, 40 hits from that user. And I had to find which was their first order from that, maybe step 35. And before 35, which was the first article they visited, maybe step 7. Or step 7, 9, 10 also were articles, but only the first one will get the credit. We used window functions here. So the first of all that I need to use window function to actually have a number for the hits, like first, second, third, and so on hit. Once I have the hits, and also I have my regjefs to match that page that I'm interested in, I need to choose from this result set the first article. So actually I'm done with this part, because the first article with the window functions, I first number it, then I choose the first one. Also there is order by hit time, so this is the first one. It's if I put descending here, it will be the last one. Or yeah. After that, I will join to first page orders. This query is not expanded on the screen, but it has the same structure. So I first write the regefs, what are the order pages, then I choose the first one as well. And then I join it further to get the details. This way, if someone visits the order page, the first article gets a credit, like an affiliate system. I don't need to maintain whatever database I have for the affiliate system. I'm just using what I have, like the hits I stored. I don't use that. Let's move forward. It's managed, it's serverless. It doesn't mean that it's a warehouse where there are no servers. It's actually, servers are behind, but it's managed. It means that you don't need to put in, there are 20 servers, you don't need to create indexes, you don't need to optimize it, you don't need to move it, and so on. It's transparent for you. For us, the advantages was that we didn't have to do manual sorting, no capacity guessing, like for example, how many machines I need on Black Friday or on Cyber Monday, and so on. No idle resources, like I bought 20 servers, but I have only 10 visitors per hour. They are idle there. The maintenance windows are non-existent, so when I deploy something, I don't need to stop the BigQuery service 20 minutes until I do my deploy and all the tests are running and so on. No manual scaling, no Black Friday intervention, for example, and no file management. Usually files, databases grow big and you need to put more disks in the server, you need to transfer it, the replication log gets behind, and so on. Our benefits continued on this. So we didn't have to provision something, we didn't have to wait for the servers to be ready, no running out of resources, no more focus on large-scale execution plans. So for example, if you run a Spark cluster, you start something, it runs 4 hours, and then it says out of heap space. You Google something, you reach on Stackoverflow, you tune something, you start again, it runs 6 hours, again, heap out of space, you start again. So it is actually, you write the query and it's there. Okay, so SQL in JavaScript. And this is actually a great new experience that you can wrangle unstructured data like a nerd. You can build custom reports with Data Studio, which is a product from the Google platform. All these details here are actually coming from BigQuery SQL database. And pretty much you write for every piece of it a query, and you have a date filter, and this interface is actually interactive. So the marketers can use it for it. Let me show you some real demo. Do you see in the back? Or I can. So let me show you this composition where we use JavaScript combined with the SQL. So the SQL is up here, and actually I have some select from it, and I actually I name it like this. It's wrapped in a JavaScript part, and the JavaScript part is written separately. So actually what it means, that the JavaScript part will get the row itself as it was the database, and it will emit something. The logic here is that you can emit nothing. So you can actually filter out rows by emitting nothing. And this is actually good, because with the join, you know that if you join something, you expand things. But when you emit something, you can choose to also emit multiple things. Like you have one row and you emit 10 things, or you have one row and emit 0 things. This is actually extremely flexible to do that. And once you have the row, you parse it, you have the object, and if you have in the object a container services array, like for example in the JSON, then you can do a for each and emit from the services the E attribute. This is a simple example for it. Of course, there is a template for it, which can be followed quickly. Okay, next one. Next one is a bit, it looks longer, but it's extremely simple. I will actually run it, if it lets me. Good. The thing here is that I created the create temporary function. In the far right, we have language JavaScript in it. And actually, my input data is this one. And with JavaScript, I actually used the split and actually put the 55. So I actually, the unstructured data, I turned into variables, or actually better into columns. This is great when you store some user input and later you need to find out address, whatever they typed in. BigQuery has a lot of gigantic databases available for public. You can go home, you can turn on the BigQuery console, and you can query all the public databases, like weather information, like Reddit, all the Reddit comments and posts. This is how cool if you could write SQL to filter out from Reddit whatever things. And for example, this example is checking the startup, entrepreneur, and productivity subreddits for book recommendations. And I define book recommendation by a link to Amazon.com. And it turns out that Lean Startup Entrepreneur, it's being recommended 62 times, and so on. You will have here how many gigabytes were processed, like almost 500 gigabytes in 10 seconds, and it cost us 240 cents, this data. And this is actually infinitely scalable. Also, all the GitHub events for the open source projects are in a big database. And also the Stackoverflow database is available for you to query. So if you want to, for example, find out as a research, for example, Google guy used the query like he wanted to find out a code line used as an answer on Stack Overflow that was actually buggy. And they found out on GitHub as well how many projects used that line wrong, and all were leaking to memory leaks. And they then contacted all of the personnel, and they told me that, and they told them that, hey, you are using this wrong, you need to change it because you crashed the browser. So how cool was that? Okay, next one, and I think the last one. You can use all kind of sorts of public information, like there is a GDAL database. GDAL is covering news coverage. All the articles on the big newspapers, and they do semantics for it. And using that semantics, you can actually count how many times different people were mentioned in the articles as well. Running this before elections, you actually get a sense of it, how many times certain person was actually mentioned. I see a lot of smiles, so actually this data it may look correct. I couldn't verify as I'm not in politics in this country, but I see a lot of smiles, so that means that somehow confirms me it's accurate. And actually before elections, what you do, you see that the candidate, it's being used or referenced a lot of the time, it may win the election. Where is my... So this concludes my talk. You can follow me on Martin Kodok. You will have the slides on SlideShare. I forgot to mention that on Stack Overflow, I'm having a lot of reputation points, like 100,000, and I answer a lot of questions for you. Maybe someone already got an answer from me. And you should use these websites to build different services. Actually, all what I presented to you is built already in this website. Thank you.